A reference guide to old wires is essential for understanding the history and safety of electrical systems. Firstly, let's consider silver braid, typically involving copper conductors twisted and wrapped in silver braid, historically used in telegraph and early telephone lines. Secondly, cloth-covered wires with rubber insulation feature copper or aluminum conductors covered in cloth and rubber. These were commonly found in early electrical systems. Thirdly, tar-covered wires are copper conductors coated in tar, primarily utilized for underground wiring. Fourthly, knob and tube wiring consists of insulated wires run through porcelain knobs and tubes, a common method in wood frame buildings. Fifthly, lead sheath cable contains insulated wires encased in a lead sheath, suitable for underground and underwater applications. Sixthly, BX cable, also known as armored cable, features insulated wires enclosed in flexible metal armor, used in residential and commercial wiring. Seventhly, Romex, or non-metallic sheath cable, consists of insulated wires bundled in a non-metallic sheath prevalent in modern electrical systems. Now, regarding National Electrical Code requirements for Romex labeling, the NEC first mandated that Romex be labeled along its length in the 1971 edition. The required labeling includes several key pieces of information. 1. The manufacturer's name must be present. 2. The wire size must be clearly indicated. 3. The number of conductors must be specified. 4. The voltage rating must be displayed. 5. The designation NM signifying non-metallic must be included. Several types of old multi-conductor cables are considered unsafe and should be replaced when discovered. 1. Knob and tube wiring is prone to insulation breakdown and poses significant fire hazards. 2. Lead sheath cable can become brittle and crack over time, leading to electrical hazards. 3. Rubber insulated wires deteriorate as they age and can also become a fire hazard. 4. BX cable with fabric insulation can develop frayed or damaged fabric insulation, creating an electrical hazard. Unlabeled Romex, particularly grey or black Romex without labeling, typically indicates manufacturing before 1971. This cable may not meet current safety standards. It should be evaluated by a qualified electrician to determine if replacement is necessary. When examining existing wiring, several factors indicate the need for replacement. If the insulation is brittle, cracked, or damaged, it's a sign that the wires are deteriorating. Look for exposed conductors, which pose a shock hazard. Aluminum wiring, commonly installed in homes during the 1960s and 1970s, can be problematic due to its tendency to loosen at connections. This can lead to overheating and fire hazards. Replacing old wiring typically involves several steps. Firstly, turn off the power to the circuit at the main breaker panel. Secondly, carefully remove the old wiring, taking note of how it was connected. Thirdly, install new wiring that meets current code requirement. Fourthly, make sure all connections are secure and properly insulated. Fifthly, test the circuit to ensure it's working correctly. Understanding wire gauges is crucial in electrical work. Wire gauge refers to the diameter of the wire. Common wire gauges include 14, 12, and 10 American wire gauge, or AUG. Smaller gauge numbers indicate thicker wires. Thicker wires can carry more current without overheating. The appropriate wire gauge depends on the circuit's amperage rating. For example, a 15 amp circuit typically requires 14 AWG wire, while a 20 amp circuit typically requires 12 AWG wire. Always consult the NEC for specific wire sizing requirements. Electrical boxes are an essential part of any wiring system. They provide a safe enclosure for electrical connections. Boxes are typically made of metal or plastic. Metal boxes must be grounded to prevent shock hazards. Boxes come in various sizes and shapes to accommodate different wiring configurations. Ensure the electrical box is adequately sized for the number of wires and devices it will contain. When working with electrical systems, always prioritize safety. Firstly, always turn off the power before working on any electrical circuit. Secondly, use insulated tools to prevent electric shock. Thirdly, wear appropriate personal protective equipment, such as safety glasses and gloves. Fourthly, never work on electrical systems when you're tired or distracted. Fifthly, if you're not comfortable working with electricity, hire a qualified electrician. Grounding is a critical safety feature in electrical systems. It provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. All metal enclosures, such as electrical boxes and appliance chassis, must be grounded. Grounding can be achieved by connecting a grounding wire to a grounding electrode, such as a ground rod or a metal water pipe. Ensure the grounding system is properly installed and maintained. Circuit breakers protect electrical circuits from overcurrents. When the current in a circuit exceeds the breaker's rating, the breaker trips, interrupting the flow of electricity. Circuit breakers come in various amperage ratings to protect different circuits. Common circuit breaker ratings include 15 amps, 20 amps, and 30 amps. Never replace a circuit breaker with one of a higher amperage rating, as this could create a fire hazard. Electrical codes and standards are designed to ensure electrical safety. The NEC is the primary electrical code in the United States. It's updated every 3 years to reflect changes in technology and best practices. Local jurisdictions may also have their own electrical codes, which must be followed. Always consult the latest edition of the NEC and local codes before performing any electrical work. While extending an existing circuit, several considerations must be taken into account. Firstly, ensure the existing circuit has sufficient capacity to handle the additional load. Secondly, use the correct wire gauge for the extension. Thirdly, properly splice the new wires to the existing wires. Fourthly, install an appropriate electrical box for the new connections. Fifthly, test the circuit to ensure it's working correctly. Electrical permits are often required for electrical work. Check with your local building department to determine if a permit is needed for your project. Permits ensure that the work is inspected by a qualified electrical inspector. Inspections help to ensure that the work is done safely and in compliance with electrical codes. Arc fault circuit interrupters, or SIs, are a type of circuit breaker that protects against arc faults. Arc faults are dangerous electrical conditions that can cause fires. SIs detect arc faults and trip the circuit breaker, preventing a fire. SIs are required in many new homes and renovations. Ground fault circuit interrupters, or GFCIs, are a type of circuit breaker that protects against ground faults. Ground faults occur when electricity flows through an unintended path to ground. GFCIs detect ground faults and trip the circuit breaker, preventing electrical shock. GFCIs are required in bathrooms, kitchens, and other wet locations. Surge protection protects electrical equipment from voltage spikes. Voltage spikes can damage sensitive electronic equipment. Surge protectors divert excess voltage to ground, protecting the equipment. Surge protection can be provided by surge protector strips or whole house surge protectors. Lighting controls can save energy and enhance the ambience of a space. Dimmers allow you to adjust the brightness of lights. Occupancy sensors turn lights on and off automatically based on occupancy. Timers turn lights on and off at preset times. Smart home technology allows you to control electrical devices remotely. Smart lights can be controlled with a smartphone or voice assistant. Smart thermostats can be programmed to automatically adjust the temperature. Smart outlets can be used to control appliances remotely. When troubleshooting electrical problems, start by checking the circuit breaker. If the breaker is tripped, reset it. If the breaker trips again, there may be a short circuit or overload. Use a multimeter to test for voltage and continuity. If you are not comfortable troubleshooting electrical problems, hire a qualified electrician. Electrical maintenance is essential for ensuring the safety and reliability of electrical systems. Periodically inspect wiring for damage. Tighten loose connections. Replace worn-out components. Clean electrical panels and equipment. Energy efficiency can save money and reduce your carbon footprint. Use energy-efficient light bulbs, such as LED bulbs. Turn off lights when you leave a room. Unplug electronic devices when they are not in use. Insulate your home to reduce energy loss. Renewable energy sources, such as solar and wind power, can generate electricity without polluting the environment. Solar panels convert sunlight into electricity. Wind turbines convert wind energy into electricity. Renewable energy systems can reduce your reliance on fossil fuels. Electric vehicles are becoming increasingly popular. Electric vehicles are powered by electricity instead of gasoline. Electric vehicles produce zero emissions. Electric vehicle charging stations are becoming more common. Electrical safety training is essential for anyone who works with electricity. Electrical safety training teaches you how to identify electrical hazards and how to work safely with electricity. Electrical safety training can help to prevent accidents and injuries. The information provided is intended for general guidance only. Always consult with a qualified electrician for specific electrical advice. Electrical work can be dangerous and should only be performed by qualified individuals. To reiterate some key points, always prioritize safety when working with electricity. Remember that old wiring may not meet current safety standards and should be evaluated by a qualified electrician. And stay informed about the latest electrical codes and standards to ensure compliance and safety. This knowledge empowers you to make informed decisions about your electrical systems and ensure the safety of your home or building. Understanding the history of electrical wiring, the evolution of safety standards, and the potential hazards associated with old materials is crucial for anyone involved in electrical work or home maintenance. By taking the time to learn about these topics, you can better protect yourself, your family, and your property from electrical hazards. The information discussed provides a foundation for identifying potential problems and making informed decisions about electrical upgrades and repairs. Remember, when in doubt, always consult with a qualified electrician.